At the beginning of 2023, the James Webb Space Telescope discovered the planet LHC 475b, which lies 40 light-years away from us. Initial studies have shown that its size and atmosphere are very similar to Earth's. You might think it would be a great candidate for finding alien life, but further measurements revealed that the surface temperature of this world is over 300 degrees Celsius. It's too hot for any organisms we know of, right? However, scientists at NASA's Laboratory for Agnostic Biosignatures believe that the problem is not too high of a temperature but our overly narrow conceptions of extraterrestrial life. What if terrestrial organisms are a rare exception to the world, and space is actually teeming with entire civilizations of creatures with completely different chemistry? In this video, you'll find out why we shouldn't beware of giant soap bubbles on which planet life is a million times faster than ours, and most importantly, what exotic life forms can now inhabit almost the entire universe. For and hide in what we've always considered absolutely lifeless. I mean ordinary stones. Scientists have spent years searching for exoplanets in the so-called habitable zones where water would not freeze or evaporate. After all, its liquid form serves as a solvent for carbon-based life as we know it. And that's where our search was usually significantly narrowed down by the fact that this element is really unique. Carbon atoms are quadrivalent, that is, they can form 4 bonds at once, even with each other. Imagine a chain of people holding hands, but they have 4 hands instead of 2. In this case, everyone will be able to hold hands not only with those on the left and right but also in front and behind. That's about how carbon works. It can form very long molecular chains on the basis of which DNA molecules in the cells of terrestrial life became possible. If you coiled the DNA strand, it would be about 2 meters long. That is, only one DNA molecule in one cell is taller than most people, and the total length of the DNA and all the cells within an individual will stretch for 20 billion kilometers. That's more than enough to stretch the molecular strands to the sun and back several dozen times. It was long believed that genuinely complex life just had no other choice but to use carbon molecules. But as it turned out, there's more than one such element in the periodic table. These are diatoms, unicellular organisms living in aquatic environments. At first glance, these crumbs are not remarkable. But in fact, you're looking at practically living stones. Diatom is the only terrestrial creature whose cell wall is composed not of carbon chains but silica. Back in 1891, the German astrophysicist Julius Scheiner suggested that under special conditions, silicon might well serve as the basis for life because it's also quadrivalent, just like carbon. But what would these organisms look like in Earth-like conditions? We can expect only silicon mushrooms similar to ordinary rocks. But they would asphyxiate in no time if carbon dioxide is a gas at normal temperature. Silicon dioxide is literally sand. But what if we change the conditions? In an oxygen-free environment, silicon would feel great. Max Bernstein, the research lead of the Science Mission Directorate at NASA headquarters in Washington, D.C., believes that extraterrestrial silicon-based life may look like a network of intelligent crystals. He suggests that such minerals would be able to store and transmit information without the help of DNA molecules. As a crystal grows, new atoms layer by layer arrive on its surface in a specific sequence. And if a small crystalline sheet breaks off from it, it'll retain these properties. It's very similar to the birth of a new organism. But even if such crystals manage to develop intelligence, it'll take them thousands of years to become a real civilization because minerals grow slow as hell. Could silicon-based creatures be any faster? This is the exoplanet KLT-9b. It lies at a distance of 650 light-years away from Earth, and its surface temperature reaches over 4,300 degrees Celsius. This temperature is greater than that of many stars. Of course, scientists didn't even try to find life on it. Maybe should, though. After all, the melting temperature of silicon is 1,410 degrees Celsius, and if carbon structures are bound to burn in such conditions, silicon will only become liquid. That's what's going to help silicon-based creatures develop exponentially faster. It appears that exoplanets, which scientists previously considered branches of the underworld, could on the contrary become the cradle for cosmic life. And that would be very common because the universe has at least 30 times more hot worlds than Earth-like ones. Only icy worlds are more numerous. But what if they're also full of life? If our theories are correct, these aliens could kill us with their breath. Indeed, in our search for alternative chemistry, not only the basic element carbon could be replaced with silicon, but also water as the universal solvent. Could another substance handle its role? This exoplanet with the tongue-twisting name has recently become a record holder since scientists recorded its surface temperature at below -220 degrees Celsius. So far, this is the coldest space body we know of. Like many other extremely cold exoplanets, it's covered in methane. Unlike water, which would instantly freeze under such conditions, methane remains liquid at temperatures down to -180 degrees Celsius. Do you see where I'm going with this? The concept of cryogenic life based on a methane solvent was described by the famous astronomer Carl Sagan and his colleague Edwin Salpeter back in 1976. But only recently have these semi-fantastic ideas received more serious scientific confirmation. In 2015, a research team led by Paulette Clancy, a chemical engineer at Johns Hopkins University, calculated that the basis for a living cell could possibly emerge in a methane environment. On Earth, cells have a flexible and elastic outer membrane made of two layers of phospholipids called a phospholipid bilayer. It separates intracellular fluids from the outside world. But scientists now speculate that instead of lipids, cell membranes could be made of acrylonitrile, a chemical compound found in cold methane. Such cell, referred to as an isotosome, could be filled with nitrogen, carbon, and hydrogen molecules known to exist in the atmospheres of ultra-cold exoplanets. These molecules would ensure the vital activity of methane organisms. But the most interesting part is that such cells could unite into spherical colonies. It follows that, in fact, astronauts in deep space should be afraid not of the acid-blooded xenomorphs but giant transparent balls filled with a strange goo-like substance. Their icy breath could instantly freeze even a person in a protective suit. Irish physicist and chemist John Bernal believed that such a life form had long thrived in space, and maybe even closer than we think. Saturn's moon Titan has long been a mystery to astronomers. I mean, this celestial body is constantly shrouded in a thick layer of impenetrable orange fog. And only in 2005, NASA's Cassini spacecraft dropped its partner Huygens probe on Titan's surface. These images stirred the scientific community. Lakes and rivers of liquid methane were discovered on Titan. Furthermore, despite extremely low temperatures, volcanic activity continues below the surface. In fact, we can see the signs of cryovolcanic activity there because it's not hot magma that erupts to the surface but ammonia and methane, a thick layer of smog formed around Titan just because of this phenomenon. What if something alive is already hiding beneath it? Not so long ago, this assumption was partially confirmed by the staff of the observatory in the Atacama Desert in 2017. They found an abundance of acrylonitrile molecules on Titan, which are necessary for azotosome-based organisms. If we consider not only icy planets but also icy moons, the universe must have many trillions of celestial bodies capable of supporting methane life. But even this abundance of extraterrestrial life is far from the limit. In the article, The Hard Problem of Life, published in 2016, astrobiologist Paul Davies and his colleague Sarah Amari Walker accused humanity of biological chauvinism. Don't worry, no one plans to cancel us yet. But here's the thing, given that all life on Earth is descended from a single common ancestor, we have no way of knowing which of its aspects are natural and inherent in all life in the universe and which are typical only for our biosphere. Consequently, organisms from other parts of the universe may not just be based on alternative chemistry, they may not even have the things we consider fundamental, like reproduction or metabolism. Davies and Walker consider the ability to accumulate energy and transmit information from generation to generation as the main minimum criteria for the functioning of life. But the ways to do it may be very different. This means aliens may lurk even in areas where neither terrestrial nor silicon nor methane organisms can survive. Some super exotic creatures could be millions of times faster than us, even though they're totally blind. The exoplanet WASP-39b is located at a distance of 700 light-years from Earth. It was discovered in 2011, and it immediately surprised scientists since the level of hydrogen sulfide in its atmosphere was just off the charts. This gas, toxic to us, could be evidence of life. Jack Holt, a professor of geology, energy, and geophysics at the California Institute of Technology, believes that another life form could thrive not on the surface of exoplanets but in their bowels. It'll just obtain the energy for life not from external sources like the star's light but directly from the mantle or core of its planet. Chemical processes in the depths of celestial bodies like the exoplanet WASP-39b release a lot of hydrogen sulfide. It could be food for special chemosynthetic types of creatures. These organisms could live right in the molten magma beneath the surfaces of planets because they could withstand temperatures up to 300 degrees Celsius. That's reminiscent of the planet 40 light-years from Earth, isn't it? But what would the inhabitants of such a world look like? To receive energy from hydrogen sulfide, such creatures would definitely need special organs like giant plates. Moreover, due to the high content of this compound in the environment, they'd need solid protection, something like the kind of shell Earth's beetles have. But that's not all. It's entirely possible that hydrogen sulfide-eating organisms would use it to create a literal biological weapon or protection against predators. That is, if we suddenly set foot on one of these planets, we'd be attacked by space bugs with plates instead of wings, spitting hydrogen sulfide-based venom. But I don't think people would survive in such a world long enough to be attacked. After all, in addition to the extremely high hydrogen sulfide levels, the radiation detected on WASP-39b exceeds Earth's norm by 300 times. But in other places where carbon and other organisms die from radiation sickness, aliens might only find an additional source of energy. British astronomer Chris Impey believes that particular extraterrestrial life forms could accumulate energy released by radioactive decay. Besides, in the absence of starlight, these organisms would develop real X-ray vision. They would be completely blind on our radioactively quiet Earth, but they would have excellent vision in the rest of the radiation-soaked universe. All this expands the list of potentially habitable worlds several times. After all, radioactive decay reactions occur in the interiors of the vast majority of exoplanets. But the most exciting thing is that they don't have to be planets. This neutron star, 400 light-years away from Earth, originated at the death place of a blue giant like Sirius. That's one of the most compact and massive objects in the universe because its radius is only about 10 kilometers. But at the same time, it's 1.5 times heavier than our Sun. The matter inside such stars is so compressed that the atoms can't stand it and literally flatten. They end up as neutrons. And although they aren't self-luminous, the residual heat of the parent star heats up this object to 1,000,000 Celsius. Under such conditions, the electromagnetic interaction that allows complex molecular chains to form on Earth just doesn't work. Instead, nuclear forces dominate, manifesting themselves at subatomic distances. Some scientists suggest that at this micro level, another life form could emerge in neutron stars. Indeed, nuclear interaction is theoretically capable of binding compressed neutrons and arranging them in patterns for transmitting information. And a neutron star definitely has no energy problems. But the most amazing thing is that such nuclear creatures would live millions of times faster than us. In 1 minute of terrestrial time, thousands of generations could change inside a neutron star, implying extraordinarily fast evolution in the formation of intelligent civilizations. In a matter of hours, our galaxy may be teeming with them right now. Because even though there are thousands times fewer neutron stars than ordinary ones, there are several 100 million of them in the Milky Way alone. We just don't see all of them. If neutron life forms ever evolve enough to communicate with their fellow beings, humans and other life forms will just find themselves inside a giant network created by aliens. And mind you, without any possibility of contact. But what if exotic life forms don't need celestial bodies at all? In fact, they would love to have our planet for dinner. The star Epsilon Eridani lies 10.5 light-years away from Earth. It's a low-mass star since it only has 80% of our Sun's mass. But its modest size does not prevent this star from being in the spotlight of the scientific community. Observations carried out by the infrared astronomical satellite in the year 2000 showed that the luminary was surrounded by a belt of unknown origin. Some scientists are sure this is ordinary space dust. But clouds of such configurations are extremely rarely observed around stars. That's why other, more open-minded researchers believe we see nothing but Dyson sphere elements built by a super-advanced extraterrestrial civilization to collect energy. It inevitably follows that this system implies the existence of an exotic life form, which we used to regard as dead matter. Back in 1949, the famous mathematician John von Neumann assumed that, at a certain progress stage, humanity would create autonomous robots with the ability to self-replicate. And according to our minimum criteria, this is a proper life form, just based on metal compounds. Without an army of such von Neumann devices, according to all models, it's just impossible to build a Dyson sphere within a reasonable time frame. But in advanced civilization, they could use them for a more ambitious purpose. In 2013, Oxford University researchers Anders Sandberg and Stuart Armstrong published a scientific paper in which they offered a way to take over the universe with an army of self-replicating robots. It'll be enough just to launch them to other stars, and the robots will do the rest independently. Upon arrival, they'll self-replicate and launch a new batch of their copies to the nearest stars and so on to infinity. All of this will be implemented without any interference from the owners. But where will living robots get the resources for such an expansion? Asteroid belts, like the one between the orbits of Mars and Jupiter, can probably be found in almost any star system. In them, space-colonizing robots will find all the metals and other materials they need in abundance. In theory, even if the civilization from the star Epsilon Eridani has already launched its drones into the solar system, we have nothing to fear on Earth. But in practice, things can be much worse. Back in 1983, astrophysicist and science fiction writer David Brin hypothesized that machines, with a great degree of autonomy, would, at some stage, rebel against their masters. Robots wouldn't even need intelligence for this, just one programming glitch in one of the generations would be enough. Given that their main task is to endlessly self-replicate for the sake of expansion, not only asteroids but also mineral-rich rocky planets like Earth risk being recycled. Perhaps such killer machines have already destroyed their civilization somewhere in the universe and are now uncontrollably flying through space in search of new victims. They're highly resilient and tenacious, but most importantly, it'll be impossible to negotiate with them because in terms of intelligence, such von Neumann devices will be comparable to bacteria. What if the fact that we still haven't found other life forms is just because all aliens are entirely destroyed by fleets of killer robots? Invisible telescopes cosmologist Edward Harrison believed that it's enough for one civilization to create such ruthless organisms for any purpose, and all living things in the universe are doomed. The only encouraging thing is that in 4.5 billion years of the solar system's history, nothing like this has happened to us, meaning the killer robots are too far away, maybe even in another galaxy. But even if the James Webb Telescope detects signs of our familiar and understandable carbon life on our nearest exoplanet, Proxima Centauri b, as soon as tomorrow, I wouldn't get too excited just yet. It may well be a trap. Let's assume we decided to send an expedition to Proxima b. Upon landing, all the sensors show ideal conditions for people, and local plants and animals are based on the same DNA molecules as we are. What could we possibly be afraid of? However, the next day, those who've tasted the fruits from this alien paradise garden will be found dead. And all because of different chirality. Organic molecules can be absolutely identical in composition and structure but not superimposable on their mirror images in 3 dimensions, like your left and right hands. Only deep chemical analysis can show this, and if the alien chirality doesn't match ours, beware of eating anything in that world. At best, you'll face indigestion, and at worst, an agonizing death from toxic products. Would you risk yourself to test compatibility with another life?